The weather affects us all, and in today's fast-moving society, the demand for accurate data for forecasts has never been greater. A crucial source of data for weather forecasting and climate change monitoring are weather satellites, which monitor the Earth's atmosphere, oceans, and land surfaces. The images and data that weather satellites transmit down to Earth are used by meteorologists to make forecasts which save lives and property by giving advance warning of extreme weather, such as hurricanes and storms. And on a global scale, the long-term data sets collected by weather satellites are also playing a crucial role in monitoring the Earth's climate. For more than 30 years, the first and second generation Meteosat satellites have been providing Europe's weather satellite service, delivering a continuous and reliable data stream from their position at an altitude of 36,000 kilometers above the Earth. Now we need to ensure that these measurements continue into the future. And at the same time, we need to benefit from the latest technology. So it is time for a new era in weather satellites. It is time for Meteosat third generation. The Meteosat series of geostationary satellites are operated by Eumetsat, Europe's meteorological satellite agency. Eumetsat was formed in 1986 and has been delivering weather and climate observations ever since. The information is supplied to the national meteorological services of the organization's member and cooperating states in Europe, as well as other users worldwide. The Meteosat third generation of satellites will be operated by Eumetsat on behalf of its member states and will provide imagery and data until at least 2040.
It is true that Meteosat third generation will provide a quantum leap of information in respect of the information that it will be able to provide in terms of accuracy, resolution, frequency, coverage, applications. And from this point of view, what is very relevant for the program of Eumetsat is the fact that it's complemented by a number of initiatives on which member states are fully involved.
Meteosat first generation began in 1977 with the launch of Meteosat 1, and this was followed by 6 further Meteosat satellites, which have consecutively delivered reliable weather and climate-related data for more than 30 years. In 2002, the second generation of Meteosat satellites began with the launch of Meteosat 8, followed by Meteosat 9 in 2005. Like their predecessors, the Meteosat second generation satellites are spin-stabilized and in a geostationary orbit, which means that the satellite orbits the Earth above the equator at the same speed as the Earth is rotating, therefore keeping a fixed longitudinal position over the Earth's surface. Meteosat 9 delivers the full Earth imagery service over Europe and Africa, while Meteosat 8 provides rapid scan images every 5 minutes of European and North African regions. Both MSG satellites have been built to the specific requirements of the Eumetsat member states and carry the Severi imaging service, which has 12 spectral channels to observe our atmosphere, oceans, and land surface, including monitoring clouds, fog, winds, ozone, snow, and ice. In addition, the high-resolution visible channel at a resolution of 1 kilometer helps weather forecasters to detect and forecast severe weather events. Severi is the most advanced instrument of its kind in orbit and is seen as the standard by the World Meteorological Organization, WMO. The Meteosat second generation series are scheduled to continue operating until at least 2018, and at which point in time they will begin to be succeeded by Meteosat third generation at the same level of annual expense.
From the user's point of view, the Meteosat satellites have given us a reliable, excellent service for many years that have been of great benefit to weather forecasting, and particularly, of course, to the forecasting of severe weather events, which is extremely important nowadays. Also a great benefit to climate monitoring. For the future, what we need is a continuity of this reliable service and also to take advantage of any improvements that can come about. And the MTG, the Meteosat third generation, will give us exactly that. Continuity into the future and new exciting features that we can all look forward to.
Meteosat third generation, MTG, will consist of a series of 6 satellites, 4 imaging satellites and 2 satellites equipped with infrared and UV sounders. The specifications of the satellites have been developed to fulfill the requirements of the Eumetsat member states. As well as providing a continuation of the current Meteosat second generation service, the MTG satellites will, for the same average yearly cost, provide an improved service over a longer time frame. One of the key payloads will be the flexible combined imager, which will produce more frequent images of finer, higher spatial resolution, 0.5 kilometers to 2 kilometers. It will also have more spectral channels, 16 spectral channels as opposed to 12 on MSG. This means that the MTG satellites will be able to deliver more detailed data on our planet's atmosphere, for example on aerosols, which is vital for improving forecasting abilities in Eumetsat's member states. The MTG series will also have a constant view of the Earth, as they will be orientated in space using 3-axis stabilization, unlike the previous Meteosat satellites, which are all spin-stabilized and so build up a picture as they rotate. Another new capability that MTG will bring includes the lightning imager, which will continuously monitor lightning flashes, cloud to cloud and cloud to ground, and so provide users such as the aviation industry with better data on the amount of electrical activity in storms in the vicinity of airports and en route. And key instruments on the sounding satellites include an infrared sounder to provide unprecedented information on horizontal and vertical gradients of moisture, wind and temperature, and the Sentinel-4 ultraviolet visible near-infrared sounder, which will greatly improve atmospheric chemistry and air quality monitoring over Europe by measuring aerosols, ozone, nitrogen dioxide, sulfur dioxide, and formaldehyde in the atmosphere from natural and human sources.
Securing MTG within the planned timeframe will lead to a continued, uninterrupted service of data from geostationary orbit since 1977. So it has the highest priority for the meteorological community in Europe. The geostationary services from the MTG will prepare us to deliver data up till 2040 through several decades. And these data are essential for the protection of human life and property and for the security of the 500 million citizens in Europe